Hello students, this video lesson is about relations and functions. A relation is two or more concepts or items that are connected or in relation to one another. In mathematics, a group of ordered pairs is relation, an XY coordinate. The relation may be displayed in a table or a set, a graph, or even an equation. So right now we're going to look at the relations in a table, a set, and a graph. The domain of the relation are all of the x values. The range of the relation are all of the y values. So here are some examples of relations. We've got a table, and in this table I have x values and I have y values. So if I want to label the domain of the relation, I simply record all of the x values. I have a -1, a 0, and a 3. If I want to record the range of my relation, I record all the y values, 2, 4, and 1. Notice that the first two relations listed have the same domain and have the same range. -1, 0, 3, and then for my range, 2, 4, 1. I just have them represented in two different ways. The first one's a table, and the second one is a set. The fancy braces that are in front of the ordered pairs, those are set notation. When you see those fancy braces, that means a set. So here's a couple other sets of relations. Over here, when I record the domain, I simply look at my x values. -1, 0, 3. And I just write those in a fancy set. -1, 0, 3. When I want to record my range, I just look at the y values. -1, 1, 1. And I'm going to record that in a set as well. But I'm going to say R to represent range. And I have a -1, a 1. And since I have a 1 again, I don't have to list it twice. I just have to list it once. Now my last relation, my domain is 0 and 3. Again, since the 0 repeats, I don't have to list it twice. I just write 0, 3. And that's my domain. And then for my range, I'm going to list all the y values, which in this case are going to be 2, 4, and 1. An easy way to remember domain and range, D comes before R in the alphabet, and X comes before Y in the alphabet. So D is for the X's, and R is for the Y's. So it's just a mathematical way of representing what the X's are and what the Y's are, domain and range. We use that in other ways as well. Now, some relations are functions, just like some equations are functions. The way I can determine if a relation is also a function, the x's can't repeat. So let's go back to what we did earlier. I have 4 different relations, and I want to see which ones are functions and which ones are not. Well, I know that the x's cannot repeat. And the only one that had x's that repeated was this last one. Oops, can't even see it now that I left it out. But notice that my x's over here repeated. All of these x's were unique So the first two, these are functions, or actually I should say three. And then this last one is not a function. They're all relations, just the one on the far right is not a function because the x's repeat. So that meant that I had two different ordered pairs, and the x had two different y values. The same x had two different y values. You can't have that in a function. Every x has to have a unique y value. So if you're wanting to know if a relation is a function, just look at the x's. Are they repeating? That is if you have the ordered pairs. Sometimes you aren't given the ordered pairs. You're just given a graph or an equation. And so there's other ways to determine whether or not that picture or that situation is a function or not. So let's go look at graphs. We know that the x's cannot repeat, that every x has to have a unique y value. Well, one way is called the vertical line test. Because if I was to draw a vertical line through the graph, and it only touches one point, then I know that the x is not repeating. But it has to do that through the entire picture. So I might have to draw more than one vertical line. I have to go through the entire picture to determine that nowhere in the picture is it touching more than one point. Notice that on the circle, when I draw a vertical line, I touch the picture twice. So that means I have two x values that have two different y values. That cannot be a function. So the first one was yes, because every vertical line only touched one point. The second picture was a no, because it touched 2 points. The third picture is also going to be a yes, because it only touches 1 point. Every vertical line will only touch 1 point. Now my last picture is a vertical line. If I draw a vertical line on top of a vertical line, it's touching infinite number of points. So that's got to be a no. Because of functions a vertical line can only touch 1 point as it goes through the graph, the entire graph. So that's how we can tell if we're given a picture. Now, if we're given equations, here are some equations that are functions. I can always take the equations and I can graph them. When I'm given an equation in the slope-intercept form, I simply go to my y-intercept, which in this case is 5, and I count out my slope, rise over 1, so I'm going up 3 over 1. And I can create a line, and I can say, okay, well, every vertical line is only going to touch 1 point. So I know that this is a function. Now, when I have y equals 3, that means that the y value will always be 3, and my x value can be anything I want it to be. So I could have, my x value could be anything I want it to be. So I can have 1, 3, 2, 3, and I'm going to have a horizontal line. Again, every vertical line that goes through that is only going to touch 1 point. So yeah, that's a function. And this other equation, which we really haven't talked about, this is going to be a parabola. And I'm going to go ahead and graph it for you. And it's going to kind of come down, and it's going to make a U. But again, every vertical line that goes through it is only going to touch 1 point. So we have to look for patterns. Math is about patterns. And notice that in all of these equations, my y is to the first power. And 1 is an odd number. If I have an equation where the y is not to an odd power, that right there tells me it's not going to be a function. It's going to have an even number of times a vertical line touches the graph. And also, if I have a x equals 3, which is going to create a vertical line because the x value will always be 3. I'll move this up a bit. So if I have x equals 3, that means the x value will always be 3. That can't be a function. So if I have a vertical line, an equation that represents a vertical line, I know it's not going to be a function. If I have an equation where the y is raised to an even power, that's not going to be a function. This one's going to be a circle. You don't necessarily have to graph these in our class, but you do need to know that when the y is raised to an even power, it's not going to be a function. This is going to be a parabola. Quite right. So it's going to be 0, 4. A little bit more like that. But it's a sideways parabola, and a vertical line is going to touch more than one point. So if the y is raised to an even power, that equation does not represent a function. Okay, function notation. In mathematics, we like to write equations as functions. So what does that mean? It simply means replacing the y value with an f of x, which represents function. So instead of writing y, we write f of x. And when I want to solve for my y, when I have it in function notation, I just write whatever my x value is inside the parentheses. So if I'm wanting to find my y when x is negative 2, I put that inside my parentheses, f of negative 2. And then I plug it into my function, my equation for x, and I solve. So if I'm looking for f of negative 2, I'm wanting to know what is the y value when x is negative 2. I can say, well, f of negative 2 is going to be 1/2 times negative 2 is negative 1, and negative 1 plus 3 is going to be 2. So f of negative 2 is going to be 2. Or in other words, when x is negative 2, my y value is going to be 2. It's just another way of writing to the domain and the range together. So if I'm wanting to find f of 0, that means I need to plug in 0 for my x. So I'm going to write 1/2. In place of my x, I'm going to put my 0. And then plus 3. And then I simplify. 1/2 of 0 is 0, and 0 plus 3 is 3. So f of 0 equals 3. Or in other words, when my x value is 0, my y value is going to be 3, which is also f of x, or f of 3. And I can write that as an ordered pair. Now they want me to find f of 4. So that tells me I need to plug in 4 into my equation. So when x is 4, I'm going to have 1/2 times 4 plus 3. Well, 1/2 times 4 is 2, and 2 plus 3 is going to be 5. So therefore, f of 4 equals 5. Or in other words, when my x value is 4, my y value is going to be 5. So that is function notation. And you'll see more of that in college algebra or pre-calculus algebra. The domain represents all the x values that work in an equation. Now, if I have a list of points, it just represents all the x values. But if I have an equation, it still represents all the x values, except equations have usually infinite number of x values. And the range represents the y's. Usually equations have infinite number of y values. Unless there's something that makes it undefined. Remember, if you have an x under the line, it causes it to be undefined. So whatever makes an equation undefined has to be eliminated from the domain. If I have an equation that represents a line, like I do over here, f of x equals 5x plus 3, that's an equation of a line. It's really in the slope-intercept form. Remember, f of x really just means y. So this is an equation in the slope-intercept form. If I go straight to my 3 and count out my 5 over 1 up 5 over 1, I can create a line. And I can see, oh yeah, it goes on and on in both directions. I have infinite number of x's and infinite number of y's because it goes up and down. Now over here on the right, that is going to create an unusual looking shape on a graph that you'll talk about more in pre-calculus. All I need to know is that x cannot be 0 because if I plugged in 1 over 0 plus 3, that's going to cause that to be undefined. So when I'm going to write my domain, I'm looking for what will work. If everything works, that means the entire number line is my domain. Domain. Now, a number line goes further and further and further to the left, that's negative infinity, and it goes further and further and further to the right, which is positive infinity. So if I want to write my domain in interval notation, I say parenthesis, negative infinity, comma, positive infinity, parenthesis, which represents the entire number line. Everything works. Everything works in this equation. Now over here, everything worked except 0. So if I wanted to write that on a number line, I'm going to have an open circle at 0 because everything is acceptable except 0. So when I go to write this in interval notation, it is going in the negative infinity direction, but it stops at 0 and it does not include 0. So I put a parenthesis around 0. So I'm going over here and all of a sudden I stop and I have to jump over. I have to jump over that 0. So we have to put a union or because in a sense there's a valley that I'm jumping over. And then I pick up on the other side, well, I'm starting but not including 0. So I'm just slightly past it. And then I'm going into a positive infinity. Not the best at drawing those positive infinities. They're like sideways x's. But infinity never stops. So you can't put brackets on an infinity. And when it approaches something but never gets to it, you have to put parentheses. So let's look at some graphs. Okay, my little dots kind of jumped around here, but those are supposed to be on the ends of this line. And this little dot's supposed to be right there. So we're just going to get rid of those. Okay, so anyway, I'm looking at this picture. Looking at this graph, and I'm just looking at this line right here. Let's not look at that dot there. And I want to know what my domain is. Well, my domain, it represents my x value. And this x value starts at -5, doesn't it? And it's going to 6. So this little line segment here, the smallest x value that's on this line segment is -5, and it includes -5. So we say a bracket -5. That's my very first x value that's on the segment. And then it goes all the way to 6, and it's a solid dot at 6, so it includes it. And it's everything in between. So if I want to graph it on a number line, I have a bracket, solid, colored in, all the way to 6, and then another bracket. Or if I want to do interval notation, I just write my bracket, -5, comma 6. So from my lowest x was -5, and my highest x was 6, and everything in between was part of the picture. Now my next picture here is it's a segment, but notice on the far left there's an open circle at -5. That means it does not include -5. It's just almost there, but just slightly past it. But now on the far right, it does include +5, so that's going to be a bracket. On a number line, I would use a parenthesis on the -5 and a bracket on the +5. And everything inside, between those two, is part of the picture. And so that's my interval notation, And then my last picture is a line. So it's going completely left, farther and farther and farther left, so farther and farther negative, and it's going farther and farther right. So that means the entire number line is my domain. So I would simply draw this in and put arrows at the end representing that every number on the number line is on that picture. And for my interval notation, I'm going to say parenthesis, -infinity, comma, +infinity. Because that's how I represent interval notation, meaning everything on the number line. So interval notation for domain and range, a bracket means includes, a parenthesis means approaches, but never gets there or never stops. It just keeps going on. So now your 5 problems that I'd like for you to complete. There we go. I was thinking it was going to be on here that you'd be able to see them all. So you have to state the domain and range of the relation, label the x's, label the y's, and decide whether or not it's a function. Do the x's repeat? Do they not repeat? Then you need to determine if the graph below is a function or not. What happens when you put a vertical line through it all the way through. And then the last is to create this equation or rewrite this equation, y equals 3/5 x plus 6, into function notation. Place the y. And then lastly, use that function and find the values of f of 0 and f of 5. Put that on paper, take a picture, and upload it. I hope you guys have a great day. Take care. Bye-bye.